Isaac and Tina disagree over which function has a greater y-intercept. Jeremy, go ahead and pick one, left or the right side.
Right.
Okay. How'd you figure out the y-intercept?
I looked at the graph and saw 0 is 4.
Yep. So you can just graph this really quickly. -2, -1, 0, 0, 4, 110, 218. And Jeremy says that this value that crosses is 0, 4. Let's write that next to your graph. 0, 4. That's what a y-intercept is. So Jeremy, what is your y-intercept? 4. Raise your hand if you got that. Now, you could have, last class, they did spend some time just figuring out the common difference. Class, what do you get there? 4, 6, 8. Class, is that linear then? No. So don't think that's linear. And then if we just do the next one, what do you get?
2.
So we know that it's quadratic, right? Second common difference means that it's quadratic. But when I asked the students when they did this, I asked them, well, did that help you with the problem? Not necessarily didn't help them, but you just need to know that it crosses, the graph crosses the y-axis at 4. Thank you, Jeremy. Nicole? How did you do this side? This one. Okay? Nicole says that the y-intercept is -4. Thumbs up, thumbs down? Is that sideways? Oh, down? Okay. This is a common mistake that students think that this is a y-intercept. Here's the graphic organizer I was talking about. Class, look at g of x. Think about which form it kind of looks like and what form do we need. What does it look like and what form do we need? Talk to your partner in 15 seconds. Nicole, what form does that kind of look like? Yeah, I got a bunch of parentheses, so that is factored form, and it kind of looks like it. It's not exactly because you have that -4. And Nicole, which form do you think we need? Let me just open this up. That's what we learned last chapter. We need to get it to standard form. If I get it to standard form, it has no parentheses, and then the C value is my y-intercept. Okay? So, the long way is if you did a box and you multiplied x minus 2 times x plus 2. A lot of work, right? Your answer is going to be a trinomial. And then you would have to take your answer and put it up here and then multiply by x minus 3. And then you would take your answer and multiply by 2. And then finally you would subtract 4. Okay? And essentially what you're doing is you're trying to look for that last value, right? Or a shorter way is just taking your constants. And let's look at what Tina wrote here. Function h of x has a greater y-intercept. The y-intercept of h of x is 0, 4. And the y-intercept of g of x is 0, -4. Sorry, I meant Isaac. Isaac has a greater y-intercept, calculated the y-intercept by substituting 0 for x. So this is the shorter way. So essentially what you're doing is you're just putting in there 0. And then you don't even have to say 0, right? So you're going to have 2 times negative 2. Class, what's 2 times negative 2? And then negative 4 times 2. Negative 8 times negative 3. And then 24 minus 4 gives us 20. So I have a y-intercept of 20 here, and I have a y-intercept of 4 here. So obviously, which one is a larger y-intercept, 20 or 4? The 20. So this side is the larger y-intercept. Now let's look at what our students have here. Isaac put in 0 for x. That gives me the shortcut of a 20. And it says this value is greater than 4, shown in the table for the function. So it looks like Isaac is correct. Let's look at Tina's. Tina says the function h of x has a greater y-intercept. The y-intercept of h of x is 4. So this part is correct. And the y-intercept of this one is negative 4. So Tina thought that this was in standard form, which was incorrect. So let's write a sentence. Isaac is correct. Tina thought g of x was in standard form, but she needs to multiply. If she multiplies it out either the long way or the short way, she'll figure out that it's 20 and not negative 4.